Assalamu alaikum. Today I will be revising with you the equations in the screening and surveillance lecture. And before we start, I would like to recap on some of the definitions that we will be talking about today, which are the sensitivity, specificity, positive and negative predictive values. If we go up here, it says that sensitivity is the ability to detect cases with the disease. So if I give 100 people this test, how many times would it test positive and tell me that this person has this certain disease? Specificity is the ability to test negative results. So basically, and exclude, to tell me who does not have the disease. So if I give this same test to 100 people, how many of them will test negative and I could exclude from this disease? Positive predictive value is correctly identified cases, so correctly positive, while negative predictive value is correctly negative, correctly excluded. Now, the reason why we need this is for some of the reasons why we use it, like here, choosing suitable screening tests. So if I'm choosing treatment, I'll use the higher sensitivity and high positive predictability. So this sensitivity and positive predictive value. While if I'm gonna choose to employ healthy people, so I want to exclude the healthy ones, I think. So we will use the specific and higher negative predictability, the other ones. Okay. Now that we know this, let us just erase all the highlights and start with the table. Now, honestly speaking, I don't think I want to use this because I like to start from the very start, from zero base. So let me just add a new page here, and let's draw the whole square all over again. Just like the last time we had the square, we will give it 4 different squares. Sorry. We'll call this one A, B, C, D. Now I know that we're talking about diseases, but to make it a little simpler and easier, I like to use an easier example: pregnancy. So pregnancy and its test over here. So of our subjects, let's say, we will have pregnant ladies and non-pregnant ladies, and we will use this new test to see how sensitive and specific and to see all that, right? And from that, we will have ladies that will be testing positive and others that will be testing negative. Okay. Now, let's say we went to a hospital. The test is new and I'm testing the test, right? So I want to see like the parameters of that test. So the test is new, so I want to test it, right? So I go to a hospital, I go to the OB/GYN section, and I will take from there 10 pregnant ladies, for example. And then I go, for example, to a cardio section, and I'll take 10 ladies that I'm 100% sure they're not pregnant. Now, from these, I will draw the 10 ladies that are pregnant in red. Let's actually draw them as circles only so that I save time. And then I'll draw the other ladies that are not pregnant, let's say in green, because why not? Okay, now let's suppose of the 10 pregnant ladies, 6 of them tested positive. So we'll draw the 6 here. Therefore, if I said 6 tested positive, that means the other 4 tested negative, even though they're pregnant. So they're pregnant, but it still tested negative. Again, When we go to the non-pregnant ladies, let us suppose that 3 of them tested positive. So we'll draw them here. They tested positive, even though they are not pregnant. And the other 7 tested negative. So they are not pregnant and they tested negative. Now, when we are calling them, we have like 4 terms that we need to keep in mind, right? True positive, true negative, false positive, and false negative. How do we determine where to put each of these terms on this table of ours? The true or false depend on whether this and that are the same, like the same sign up and on the left. Okay? If they are the same, that means we write true. If they are not, then we write false. So in the first one, they're the same. So we write true. On the second one, this is a negative, this is a positive. Therefore, we would write false. Same here. This is a positive and this is a negative. They're not the same. Therefore, it's also false. And the last one, they're both negative. So we'll write true. Therefore, we're left with the last part, which is positive and negative, right? We will depend on this. It's true that they're positive. Therefore, it tested positive. Therefore, it's positive. They are negative, but it tested positive. Therefore, it's false positive. So on this line, they're both positive, but one is true, one is false. On the other one, it's negative. So they're pregnant, but they tested negative, therefore it's false negative. And the last one, they're negative and they tested negative, therefore it's true that they're negative. It's true negative. Okay? So now that we plotted them as given here, so now we will move on to the definitions we talked about earlier, right? So what we did have was sensitivity, specificity, and the positive and negative predictive values. An easy way that I remembered these terms was when it starts with an S, it's gonna be vertical. While when it starts or it has a predictive value in it, it will be horizontal. So sensitivity will go down like this, while specificity will go up like that. Sensitivity will be A over A plus C times 100, that's the percentage. While specificity will be D over B plus D times 100. So sensitivity, how sensitive a test is. So what does that mean is, when I have all the pregnant ladies or all the diseased people, and I test all of them with the same test, how many times will the test give me a positive result? This percentage is how sensitive it is. When I say how sensitive, it means it is able to detect it easily. Okay. And when the number is positive, or not a fraction, when the number is big, that means it's even better. So here, for example, we said that our numbers, if we're going to plot them, it's going to be 6 out of 10, 6 over 6 plus 4, which is 10, times 100, which will equal to 60%. So it's 60% sensitive because it was able to detect out of all the 10, 6 of them, which is good, above average, right? It could be better, obviously, but let's say it's good, right? While when we're talking about specificity, how specific it is, we're excluding the negatives, right? So out of the 10 that are not positive, that are not, how do I say this? That are not uh, pregnant here, or that don't have the disease in other cases, how many of those negatives will test positive and how many will test negative? We want them to test negative because we want our test to be specific. Because also, the bigger the number here, the better, because we're going from down up, mind you. Because why do we not want it to be a big number? Why do we want it to exclude them? Is because if my test is giving me false negatives and true positives all the time, how is it accurate? It's not that accurate, right? Keep in mind, sensitivity we use it for treatment, while specificity we use it for employment, as mentioned earlier. So in our case here, I'm not gonna calculate much. I'm just gonna plot in the numbers. It's gonna be, even though the numbers are easy, actually, you know what, whatever. So here we had 7 over 7 plus 3, which is 10, times 100. So it's 70% specific, you know? Now that's for the sensitivity and specificity, the vertical parts. Now let's go to the horizontal parts. If you notice here, it says A over A plus B and D over C plus D. What we're looking for is the truths, the true positive and the true negative. Again, we're always looking for the true. That's our basics. That's the one that we put on top. Okay. So the first one, it was AD. Now it's also AD, but this time it's going this way and that way. Okay. So we'll put the positive predictive value. It'll be the positive one, right? The A and A. The A, basically positive and positive. While the negative predictive value will be the D, which is negative and negative. So let's plot them. Let's plot them. A, which is 6, over A plus B, which is 6 plus 3, 9, times 100, which is 66%, or 67% basically, or 66.7%. Let's just say 67%. While the other one, the negative predictive value, it is D, which is 7, over D plus C, which is 11, times 100, which is 63.6%, or let's say 64. Okay, so the predictive value, I'm predicting that of the, if we're talking about the positive predictive value, I'm predicting that of the positive results, how many were true and how many were false. And same for the negative, how many were true negative and how many were false negative. And this will also increase to the accuracy of my tests. And again, just as a reminder, positive predictive value is for treatment, and negative predictive value is for employment, as mentioned here. And we're always aiming for the higher. Now, after we finish all these, let's go and solve the question at the end. It says here, a critical care fellow is interested in whether the auscultatory finding of pulmonary rales can accurately predict hypervolemic state. Let's just highlight that real quick. Hypervolemic state. So that's the, let's say, the disease, I think. And that's the auscultatory finding of pulmonary rales is the test we're using, right? And then it conducts a study, sorry, in 100 patients with volume overloaded state, confirmed by Swan-Ganz catheter in his hospital's cardiac critical care unit, whatever. So basically, we are sure that these are positive people. He also recruits 100 patients with avolemic state, confirmed by also the Swan-Ganz catheter. He subsequently, so 100 and 100, these are the numbers we care for, 100 patients with and 100 patients without. He subsequently examines all patients in the unit for rales and finds that 80 patients in the hypervolemic, 80 of the positives, have rales in comparison to 50 patients in the evolemic, the negatives, that tested also positive. So, okay, which of the following is the positive predictive value rales? Okay, let's see. Let's draw this square. The lines A, B, C, D. According to the doctor, we will have our papers, so we could do that there during the exam, right? We have 100 over here and 100 over here. That's positive, negative. Let me just put it there real quick. Positive and negative. So that's true positive. So out of the 100, they said that 80 patients in the hypervolemic. Okay, so 80 here. And in comparison to 50 patients in the evolemic. So I think it was also here. So false positive. So if you want to fill it up, it's going to be 100 minus 80, which is 20, and 100 minus 50, which is 50. Okay, now what's the question here? The direct question. Positive predictive value of rales. Positive predictive value, we agreed it goes that way. Horizontal from left to right. So it's A over A plus B times 100. Now here, since it's not giving percentages in the question, we're gonna ignore the part that's times 100, right? So never mind it. He made it easier, more straightforward for us. So A, which is 80, over A plus B, which is 80, plus 50, which is 130. 80 over 130. So the answer here is C. Thank you, everyone, and I hope you have a nice day.